From a high-altitude vantage point, a river cutting through a developed valley appears to be a fortunate accident of geography, a remaining strip of wilderness. This is Devon's Sid Valley, where the River Sid corridor acts as a continuous green artery, connecting the town center to the upper catchment. While these riverside parks may appear self-sustaining, they operate under a regime of constant, deliberate maintenance. The Sid Valley corridor functions as a managed spatial network, with every acre assigned a specific ecological role under the Devon Local Nature Recovery Strategy. This map details recovery zones driven by the strict 20% biodiversity net gain mandate facing developers. Meeting this threshold requires more than traditional planting. Planners use an ecosystem heterogeneity model, subjecting adjacent parcels to radically different intervention regimes, creating a diverse habitat mosaic. By deconstructing the corridor from its urban center to the upper catchment, we can see how these distinct zones interlock to support the wider network. This makes ecological resilience an applied spatial engineering challenge, relying on deliberate friction between management zones. We begin at the first nodes in the lower valley: Sid Meadow, Margaret's Meadow, and the community orchard. These are designated high-intervention zones. Maintaining unimproved grasslands presents a specific botanical challenge. If left alone, common, vigorous grasses naturally dominate the soil, suffocating delicate, high-value wildflowers. To prevent this, the Sid Vale Association employs a traditional cut-and-remove hay management regime. The rule is strict. All grass cuttings must be physically removed from the site. If cuttings mulch into the ground, they over-fertilize the earth. Removing them deliberately starves the soil of excess nutrients. This low-nutrient environment suppresses the aggressive grasses, allowing indicator species like pignet to establish a diverse botanical base. In Sid Meadow, human labor is paired with a biological tool, the Yellow Rattle strategy. This soil cross-section illustrates the mechanics of Yellow Rattle, a biological grass suppressant. Its roots latch onto dominant grasses, siphoning nutrients and stunting their growth. This semi-parasitic behavior suppresses grass without chemical herbicides. As the canopy opens, these spatial voids provide light for delicate orchids to emerge. Nearby, the community orchard is managed as a priority habitat mosaic. The objective here is twofold: preserving the genetic heritage of West Country fruit varieties and establishing habitat complexities, like dead wood log piles to support beetles and fungi. Protecting this environment requires strict control over external inputs. The orchard is a designated dog-free sanctuary. Canine waste is nitrogen-rich. Introducing that nitrogen would alter the balanced soil chemistry, favoring aggressive grasses and undermining the nutrient-starved conditions required for spring wildflowers and their pollinators. The diversity of these meadows relies on a specific tension. They require relentless human intervention to maintain the nutrient-starved conditions that keep aggressive grasses at bay. Moving north into the upper bayas, the strategy shifts at the 1.9-acre Livonia Road field. In contrast to the labor-intensive meadows, this area is managed as unruly scrubland under a low-intervention philosophy. This matrix outlines the different objectives. Here, the goal is to follow the regional directive to delight in the unruly. Management rejects the manicured aesthetic of a public park in favor of high structural density. This unkempt scrub provides dense overhead nesting cover, as well as sanctuary for small mammals that would be exposed. Within these thickets, managers deliberately retain pioneer species like silver birch. Silver birch supports hundreds of distinct insect species, which in turn sustain local bird and bat populations. Structurally, this scrubland functions as a biological buffer zone for the wider corridor. The dense brambles form a physical barrier, protecting the sensitive inner meadows from the noise and light pollution of the adjacent Livonia Road. We see a similar adaptive structure in Gilchrist Field, where ash dieback disease forced the felling of mature trees. Instead of immediate replanting, the resulting canopy gaps are used to stimulate dormant ground flora, increasing the diversity of the understory. Intentional ecological neglect provides the physical sanctuary and dense defensive buffers that open meadows cannot offer. At the northernmost nodes of the mapped corridor, we reach the riparian transition zones of Fortescue and Sidford. Here, the focus moves from stationary habitats to systemic transit. This zone operates as a green highway for wildlife movement. To facilitate this, the network uses species-specific navigation roles, such as the dark corridor strategy designed for the lesser horseshoe bat. This nighttime heat map shows restricted artificial lighting around ancient hedgerows, maintaining an unlit dark corridor for bats. Parallel to this, low-intervention riverbank management protects migrating European otters. Fallen wood is left untouched, providing essential resting couches for otters traveling to the coast. Moving further upstream into Sidford, the area behind the rugby club represents a critical source-to-sea front line for the entire river catchment. This node faces a systemic threat: heavy upstream infestations of the invasive Himalayan balsam. Without upstream biocontainment, the seed load from invasive species creates a constant pressure that threatens to overwhelm the specialized habitats downstream. Teams engage in balsam bashing here to stop millions of seeds from washing downstream and outcompeting native flora in the lower bias. Alongside physical containment, this node hosts water quality monitoring through the Riverfly and Back-to-Quick programs at the Snodbrook confluence. This testing tracks agricultural nitrate and phosphate runoff, identifying chemical threats before they reach the sensitive ecosystems in the lower valley. The survival of microhabitats downstream is dependent on this macro catchment defense. Biocontainment and chemical monitoring at the top of the system protect the integrity of the entire network. Returning to the full topographical map of the Sid Valley, the underlying architecture of the system becomes visible. Isolated, distinctly managed microhabitats lock together to form a cohesive, resilient corridor. The meadows function as high-intervention botanical and pollinator engines. The unruly scrub acts as a structural sanctuary and acoustic buffer, and the upper riparian catchment serves as a defensive bottleneck against biological and chemical contamination. Governing all of these spaces is the 20% biodiversity net gain mandate. Meeting this standard moves beyond passive conservation, requiring active, data-driven management of every landscape feature. Modern conservation is a spatially interdependent engineering challenge, demanding precise control over human intervention across every inch of the biological corridor.